Normally the next step would be to use EVGA's supplied plastic standoff to complete the motherboard tray installation with the standoffs. However, in this case, as is the case with most boards of this size and weight, using heavy air coolers, such as the two Prelimitech Mega Halum Revision Bs that I'm putting on my board, they all include 1366 socket backplates, large metal plates that are designed to have the nuts and bolts and connections go through the board and help offset the weight of such heavy coolers and prevent the board from warping and torquing. Now in this case, EVGA has supplied two pre-mounted heavy-duty backplates for the board. As such, please see the attached imagery for a view of those backplates. Allow me to briefly walk you through the installation of a Mega Halum's heatsink. The first step is to take one of the supplied rubber grommets and place it over the 1366 mounting hole. The second step is to take these supplied double washers, double screws, and thread the short end, which ironically in this case happens to be the thicker side, and screw it into the hole. Repeat this step for all four 1366 mounting points. The next step is to install the CPU in the CPU socket. The first step in installing most any modern CPU is to raise the load plate. This is done by pulling away and upward from the socket. Then, raise the load plate. Be sure to remove the CPU insert. The next step is to install the CPU in the CPU socket. As can be seen, most CPUs today have key marks, triangles, and other one-way identifiers to ensure that it is only installed in the proper orientation successfully. The CPU should generally not move around if it is seated properly in the socket. As such, it says they have zero insertion force and should just drop and line up in the proper orientation. The next step, close the load plate. The next step, while optional, ensures good thermal compound, or TIM, thermal interface material, or grease, however you'd like to call the bonding material, insulating material, to the CPU socket. The next step is usually to clean the CPU die with alcohol. To continue the heatsink installation, remove both the top threaded screws off the support threads and place on the aluminum crossbar corresponding to the socket. Appears to be good news for Megahalum's owners with SR-2s. It looks like you can also mount the supporting brackets by 90 degrees, just barely, as you can see by nearly touching those heat sinks at the top of the frame. The original position you saw would mean that the heatsink's broadside would be running from the top to bottom of the board, from the fans from the RAM down through the PCIe Express cards. I've decided to see if reorienting them would provide better airflow. Once I mount the cooler, this means the broadside will be facing the camera and the fans will orient themselves in the push-pull configuration from the front to the rear of the case. The next step is to mount the Megahalum cooler to the heatsink. Uh-oh. As you can see, make sure your heatsink is in the proper orientation so that you can clear the height of your RAM, as well as ensure that you do place thermal compound on both the CPU socket and the base of the heatsink. Next comes the RAM. Simply first pull off the adhesive protection, and you're good to go. Be sure to also refer to EVGA's manual and these RAM charts for installing different amounts of DIMM ECC error correction code or non-ECC RAM modules with this board. My particular RAM of choice for this board are Mushkin brand Redlines. They are PC-12800 or DDR3 1600 speed. These are tri-channel 3x2 GB each. For anyone that happens to care, the timings are 68624. RAM installation, like any board, is fairly straightforward. Simply press the tabs out to the sides, install with the notch groove, and press down until it locks. One quick mistake on the timings there. They are actually 88824. Small print, visual mistake. You know, it happens. So anyway, now that we have one stick of RAM correctly installed in the DIMM socket, simply repeat the process for the other sticks of RAM. Since I have 12 gigs of RAM for now in this system, I'll also be populating the second processor's identical RAM banks. The next step is to apply thermal compound to the processor. Now it's time to place the thermal compound on the CPU socket. Normally, I'd use Arctic Silver 5, but since I do not happen to have any that would be fresh, I've decided to go with Prolema Tech's included thermal compound. Again, this is to simply, not really bond, but to simply fill in as a heat mitigator transfer from all the microscopic pits and valleys between the surface of the heatsink and the surface of your cooler. Well, some people will use different conventions for spreading the thermal compound around. The general consensus online seems to be that a small grain of rice or so in size is the perfect amount. Too little thermal compound and you won't fill in any of the valleys and make proper contact with the heatsink. Too much thermal compound and the heat will not properly transfer from the CPU to the heatsink. As always, be sure to not get any of the thermal compound on other parts of the board or your skin. As far as I'm aware, you can wash thermal compound off with soapy water. I'm using a folded index card to properly smooth out the TIM, the thermal compound, across the entire surface of the processor. Now, with what I hope is a fairly smooth and even amount of thermal compound applied to the processor, I will dab and then touch down the heatsink. Be sure to remove the protective label. Be sure to also swab the bottom of the heatsink. Be sure to also remove the foam insert between the heatsink plates. After applying a small, maybe half a pea-sized piece of thermal compound to the bottom of the heatsink, we will now carefully lower the heatsink into place. As can be seen, you can see the heatsink just barely clears the RAM. Continue installing the heatsink by placing the center brace bar through the heat pipes and into the pegs below. Complete the heatsink installation by using a Phillips screwdriver to drive down these spring-loaded screws through the top plate and into the screw hole below. With the completion of screwing down the screws tightly, one heatsink installation is complete. The final step in the cooling solution for the heatsink is the addition of fans. With this type of heatsink you can do a push, push-pull, or just pull. It depends if you'd like one or two fans, though two seem to offer better cooling. For my particular choice, I am using 120mm clear red LED Lian-Li brand fans. The process is very simple. Prolimitech actually includes not 2, but 4 in their most recent kits of these little wire fan brackets. I will go over installation in just a moment. The final step in installing the fan to the heatsink is taking your fan along with Prolima's included wire hangers. There are now 4 of these in a kit compared to 2 previously. This way you can do a 2-fan configuration with 2 wires each. The first step normally is to take the triangular part with the groove, place it into the screw holes of your mounting fan. However, these fit so tightly, I found it's better for me to do the reverse. While the installation is not overly difficult, it might take you a couple times to get it right. First, place the wire in the heatsink groove. Then, bring the fan up. It will touch this mounting screw, but it still fits fine. Then, simply bring the wire around and plop it into the screw for the fan. Repeat the process for the other side, and you will have your fan installed.